Let's think about inverse functions. This is going to be a pretty quick treatment, mostly suitable if you've seen it once before, but it can serve as an introduction. Let's look at a function to start with that's going to give us a little bit of a problem. We've got y equals 1 plus x squared, and I'm going to be very graphical in a lot of this, and really a lot of this is making sure we know how to graph inverse functions, and how to think of them graphically. So here's the graph of y equals 1 plus x squared shifted parabola. And I'd like to know, can I solve, so that's f of x, that's our forward function. And I'd like to know, can I invert that? Can I find x given y? Instead of the usual way, input an x and output the y, can I find x if I'm given the y? Can I find the input given the output? Okay. Well, there's a very big problem here, and that's that suppose if I give you y equals 5, then there's two choices. X equals plus or minus 2 both work. And graphically, that's corresponding to the fact that corresponding to the line y equals 5, if I set this equal to 5, that can be interpreted as intersecting this graph with that horizontal line. There's two intersections. There's not one choice. For some cases, that's okay. But if I want to find a unique x given y, in other words, if I want to define a function called the inverse function that takes what was the output and produces the input that it corresponded to, that's not going to work here. That's not going to be okay. And graphically, we can see that that's going to happen anytime a horizontal line intersects twice, because that's going to be something where different x values, like here plus or minus 2, give the same y value. And so you're not going to be able to solve this problem. Okay, so that's called the horizontal line test graphically. It's similar to the vertical line test. The vertical line test is to figure out if it's a function at all, even the forward function. But given that the forward function is okay, the horizontal line test tells us if we're going to be able to invert the thing. And the terminology here is that when two inputs go to the same output, we say f is not 1 to 1. We're not having one input to one output. It's 2 to 1 mostly here. Okay, so it's not 1 to 1. Sometimes that's abbreviated as 1-1. Okay, and if that's not true, then I can't find an inverse function. I can't solve for x in terms of y and get one unique answer, which would make it a function. Okay, so let's look at one that works. Okay, I'm going to look at one. It's going to be slightly complicated because I want to have enough features in the graph to have an interesting discussion about graphing it and its inverse. So 1 over 1 plus x, let's look at the graph of that thing. Not talking about inverses yet, just graphing the function itself. Well, 1 over x is actually a very standard function. Okay, that's the first example people usually see of a function with vertical asymptotes. It gets really big, 1 over, so this is 1 over x here. I haven't shifted it yet. It's going to be a shift of that. Okay, 1 over x is something where if x is very small, close to 0, then the y values blow up to infinity. Get very big, in other words. And if x is very big, the y values are small. So when x is very big out here, and out here the y values are small. So what does the 1 plus do? It's attached to the x. So all that's going to do, so I can erase it without erasing my axes, is it's going to shift it to the left by 1 unit. Okay, so that asymptote is going to show up here. Okay. Where's that intercept? Oh, that's pretty easy. When x is 0, y is 1. So that's 0, 1. Okay. And then that other branch has been shifted back over here. Okay. So let's look at the algebra of inverting this function. If this is f of x, and some of the concepts of inverting, and then we'll look at the graphical stuff probably in the next video. Okay, so I want to take this equation and I want to solve for x in terms of y. That's really what, algebraically, that's what this amounts to. Okay, so I'm going to take 1 over both sides, And for some reason, students don't tend to realize that that's something they can do. You could also cross multiply, but sometimes it's easier. If what you're after is entirely in a denominator, just take 1 over both sides, okay? And then subtract 1, okay? And so x is 1 over y minus 1, okay? So that tells us if you gave me the y value, then I'm going to be able to find the x value. And it's not even that hard, okay? Just 1 over whatever that value was minus 1. So here's the thing, though. There's one other step that I want to do that in some ways is kind of minor, but it actually is key to the thought process and actually is key to the graphing process as well. So let's think about the schematics here. I had this function here. It had a particular formula, but for right now, let's just think of it as kind of a black box that I put inputs in, processes through this machine, and takes an output. Okay. So now what I've done is I've given a formula. This 1 over y minus 1 formula will be the formula for the machine that takes that output and recovers the input that it must have come from. Okay, and so this is the formula, the 1 over 1 plus x formula. Okay, now here's the thing. I'm going to take this f inverse and I might use it in all kinds of different contexts where it's not really that important that it came from f, that it was the inverse of a specific function. And it's going to be weird if I always insist that its input be called y instead of x. In fact, it's going to even seem very strange. If I think of a function, usually I want the input to be called x and the output to be called y. The only reason you were using x and y in their roles here is that we're still tied to this forward function. So we switch the letters. And you could do this at the very first step as well. The first step could be, hey, I'm going to switch the letters x to y. And usually I actually recommend that, but I just wanted to kind of come out organically here. We switch the letters, okay, and the way what that does is it gives me a formula in terms of x, okay, and that's going to be the formula for f inverse of x, okay. So we're kind of doing something that's a little weird from the perspective of the forward function. We're relabeling its input as y and its output as x, which if we were caring about the forward function more than the backwards, the reverse function, the inverse function, that would be weird. But now that we're caring more about this part of it, it actually makes a lot of sense, okay. So we now have the formula f inverse of x is 1 over x minus 1. So there's just 2 steps. Solve for x in terms of y, switch letters. And if you switch letters first, then you're going to be, if you switch the letters first, it would be x equals 1 over 1 plus y, and then you're just going to solve for y. You'll get the same answer. Doesn't really matter. Okay, so that's a basic example. Now, sometimes, like with trigonometric functions, you don't have a formula that you're doing algebra to invert. That you just have to name the function, okay, like the inverse of the sine function is inverse sine. We can't do this kind of algebra, but I wanted to demonstrate how that algebra often works. But this idea of a forward function and a reverse function, or an inverse function, to be more technically correct, and the idea that switching the letters reminds us that we're entering this new world where we're going backwards, but we want our traditional conception of x being in the input and y being the output. That's actually very, very useful. And the other one's maybe going to end up being a little bit longer because it's going to do all the graphing stuff, but I'll put it all in the second video.